Alright, learning guide problem number 4. Use the right triangle below to show where the first Pythagorean identity comes from. Apparently the formatting got messed up. That theta should be right there. I don't know what that little dude's doing right there. Let's make this more official. I drew over it with white ink. Okay, so it's called the Pythagorean identity because it comes from the Pythagorean theorem. Pythagorean theorem says leg squared plus leg squared equals hypotenuse squared. So with how we've labeled this right triangle, like we typically use it in trigonometry, we can say that a squared plus o squared equals h squared. And a lot of people would be tempted to say then, well, we probably want to write this as h equals the square root of a squared plus o squared, right? Well, not quite, because think about what we can do with this algebraically. We can do more with it if we don't have stuff in the square root. So think about this. What if we made the length of the hypotenuse equal to 1? Well, how could we adjust our equation to represent that? Well, we could divide everything by h squared. And so I'm going to divide everything by h squared. And since the numerator and denominator is squared in all of these terms, I can factor that squared out to write it as the ratio squared. So I can write this as a over h squared plus o over h squared, sorry, not plus, but equals h squared over h squared is 1. And so, notice what we have. A over h is the ratio of sides that is equivalent to cosine. So really, I have cosine squared of that theta value plus o over h, opposite over hypotenuse, is sine squared of that theta value, and that equals 1. That is the first Pythagorean identity. That's the main one. But we're going to do some manipulations to it. Manipulations, yes, that's what I said. We're going to manipulate this equation algebraically and come up with the two other ones. And the two other ones are very easy to get from this. All we're going to do is divide everything by cosine squared theta. Everything. And I mean everything, even that 1, because then what we get is cosine squared theta over cosine squared theta equals 1, plus sine squared theta over cosine squared theta is tangent squared theta equals 1 over cosine squared theta is secant squared theta. And so we now have our second Pythagorean identity. But what if we hadn't divided by cosine? What if we divided by sine instead? So now let's divide everything by sine squared theta, and sine squared theta. Well, then I have cosine squared theta over sine squared theta is tangent, lies, I'm a liar, is cotangent squared theta, plus sine squared theta over sine squared theta is 1, equals 1 over sine squared theta is cosecant squared theta. And so now I have the third Pythagorean identity, and with each of these identities you can always rewrite them algebraically. Subtract cotan from both sides to get 1 equals cosecant squared minus cotan squared. Add secant squared to both sides and subtract 1 to get tan squared theta plus secant squared theta equals negative 1. I mean, you can manipulate them any way you want and then simplify things algebraically, and that is typically how we use them. I guess I should read the instructions more carefully because all this says is show where the first one comes from. Well, that's where the first one came from.